Topic of this presentation is MOSFETs. Let us start with main contents of it, which are Introduction to MOSFETs, MOSFET Structure and Operation, Types of MOSFETs, MOSFET Characteristics, MOSFET Applications, Advantages and disadvantages of MOSFETs. MOSFET stands for metal oxide semiconductor field effect transistor. It is a type of transistor that is used in electronic circuits to switch and amplify signals. MOSFETs are made up of three layers: the source, the gate, and the drain. The gate is separated from the source and drain by a thin layer of oxide. When a voltage is applied to the gate, an electric field is created in the oxide layer, which controls the flow of current between the source and drain. MOSFETs are made by a process called controlled oxidation of silicon, which creates a thin layer of metal oxide on top of the semiconductor substrate. The metal oxide layer acts as an insulator and forms the gate terminal of the MOSFET. The source and drain terminals are created by doping the substrate with impurities of opposite type to the substrate. For example, if the substrate is p-type, then the source and drain are n-type, and vice versa. The MOSFET can be either n-channel or p-channel, depending on the type of substrate and doping. The MOSFET works by applying a voltage to the gate terminal, which creates an electric field that changes the conductivity of the channel between the source and drain terminals. MOSFETs are made up of three layers: the source, the gate, and the drain. The gate is separated from the source and drain by a thin layer of oxide. When a voltage is applied to the gate, an electric field is created in the oxide layer, which controls the flow of current between the source and drain. MOSFETs are classified into two types: enhancement MOSFETs and depletion MOSFETs. Enhancement MOSFETs are further classified into p-channel and n-channel MOSFETs, while depletion MOSFETs are classified into p-channel and n-channel MOSFETs. The pinout of a MOSFET depends on its package type and configuration. The most common package types are TO220 and TO92, which have 3 pins: source, S, gate, G, and drain, D. The pinout diagram shows how the pins are arranged and labeled on the MOSFET. It also shows the polarity of the device, which indicates whether it is an N-channel or P-channel MOSFET. An N-channel MOSFET has a positive voltage on the drain and a negative voltage on the source, while a p-channel MOSFET has a negative voltage on the drain and a positive voltage on the source. Some examples of MOSFET pinouts are IRF 520, 2N7000, and IRF 540N, which are all N-channel power MOSFETs with different specifications and applications. The IRF 520 is a type of transistor that can be used to switch high-power devices on and off. Some points to explain it are: it is an N-channel MOSFET, which means it has a metal oxide semiconductor field effect transistor structure and a negative voltage on the gate terminal turns it on. It can handle a maximum drain source voltage of 100 V, a maximum continuous drain current of 9.2 A, and a maximum power dissipation of 60 W. It has a low gate threshold voltage of 4 V, which means it can be easily controlled by microcontrollers like Arduino or Raspberry Pi. It has a fast switching speed and low on resistance, which makes it suitable for high efficiency and high frequency applications. It has an avalanche rugged technology and is 100% avalanche tested, which means it can withstand high voltage spikes and surges without damage. The 2N7000 is a type of N-channel enhancement mode field effect transistor, MOSFET, that is used for low-power switching applications. It is a widely available and popular part, often recommended as a useful and common component for hobbyists. Some of the features and applications of the 2N7000 are: it has a high-density cell design for low on-state resistance, RDS(ON). It can be used as a voltage-controlled small-signal switch. It is rugged and reliable, and can handle high saturation current. It is suitable for low-voltage, low-current applications, such as small servo motor control, power MOSFET gate drivers, and other switching applications. It is housed in a TO92 package, with lead 1 connected as the source, lead 2 as the gate, and lead 3 as the drain. The IRF540N is a type of N-channel power MOSFET that can handle up to 33A and 100V. It has a low on-state resistance of 0.044 ohms, which reduces power loss and heat dissipation. It comes in a TO220 package, which has 3 pins, source, S, gate, G, and drain, D. The pinout diagram is shown. The IRF540N can be used for various applications, such as DC motors, inverters, SMPS, lighting, load switches, and battery-powered devices. It has a low gate threshold voltage of 4V, which makes it suitable for use with microcontrollers like Arduino. You can find more information about the IRF540N in the following sources. A voltage is applied to the gate terminal of the MOSFET, which creates an electric field across the gate oxide layer. The electric field induces a charge layer on the surface of the semiconductor substrate, forming a channel between the source and drain terminals. Depending on the type and mode of the MOSFET, the channel can be either N-type or P-type, and can be either enhanced or depleted by the gate voltage. The current flows through the channel from the source to the drain and is controlled by the gate voltage and the channel resistance. The gate terminal does not draw any current from the circuit, as it is insulated from the channel by the oxide layer. MOSFETs are classified mainly into 2 types. Enhancement mode MOSFETs. Depletion mode MOSFETs. Whereas enhancement mode MOSFETs are equivalent to normally open switches because they do not conduct when the gate voltage is 0. When a positive voltage is applied to the N-channel gate terminal, then the channel conducts and the drain current flows through the channel. Enhancement mode MOSFETs are commonly used as switching elements in most integrated circuits. While depletion mode MOSFETs have a physically implanted channel connecting the source side and the drain side. Depletion mode MOSFETs are generally known as switched-on devices because these transistors are generally closed when there is no bias voltage at the gate terminal. If the gate voltage increases in positive, then the channel width increases in depletion mode. As a result, the drain current through the channel increases. The depletion mode MOSFET is a relatively rare device and is not commonly used. Here are some of the applications of MOSFETs. MOSFETs are widely used in electronics and power applications because they have high switching speed, low power consumption, high input impedance, and high efficiency. They are used as switches in power electronic circuits as they can switch on and off very fast, which allows them to handle high frequencies and reduce power losses. MOSFETs can also handle high currents and voltages, which makes them suitable for high-power applications. MOSFETs are the primary elements of computer processors, semiconductor memory, image sensors, and most other types of integrated circuits. Discrete MOSFET devices are widely used in applications such as switch-mode power supplies, variable frequency drives, and other power electronics applications where each device may be switching thousands of watts. Radio frequency amplifiers up to the UHF spectrum use MOSFET transistors as analog signal and power amplifiers. MOSFET devices are also applied in audio frequency power amplifiers for public address systems, sound reinforcement, and home and automobile sound systems. MOSFETs are tri-terminal, unipolar, voltage-controlled, high-input impedance devices that are widely used in electronic circuits. They can be classified into two types, depletion type and enhancement type, depending on whether they possess a channel in their default state or not, respectively. Further, each of them can be either p-channel or n-channel devices as they can have their conduction current due to holes or electrons, respectively. In general, any MOSFET is seen to exhibit three operating regions viz. Cutoff region, ohmic or linear region, and saturation region. The cutoff region is a region in which the MOSFET will be OFF as there will be no current flow through it. In this region, MOSFET behaves like an open switch and is thus used when they are required to function as electronic switches. The ohmic or linear region is a region where the current increases with an increase in the value of dot when MOSFETs are made to operate in this region. They can be used as amplifiers. In the saturation region, the MOSFETs have their constant input of an increase in and occurs once exceeds the value of pinch-off voltage. Under this condition, the device will act like a closed switch through which a saturated value of flows. As a result, this operating region is chosen whenever MOSFETs are required to perform switching operations. Here are some advantages of MOSFET. MOSFETs provide greater efficiency while operating at lower voltages. They have high input impedance, which results in high switching speed and low power consumption. MOSFETs can handle high currents and voltages, making them suitable for high-power applications. They are easy to manufacture. MOSFETs can be operated in either enhancement mode or depletion mode. They have high drain resistance due to lower resistance of channel. MOSFETs support high speed of operation compared to JFETs. And among disadvantages are: MOSFETs are more expensive than BJTs, bipolar junction transistors. They are more susceptible to damage from electrostatic discharge, ESD. MOSFETs have a higher input capacitance than BJTs, which can cause problems in high-frequency applications. They are more sensitive to temperature changes than BJTs. MOSFETs have a higher gate-to-source voltage than BJTs, which can cause problems in low-voltage applications. Thanks for watching. That's all for today's video on MOSFETs. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topic you want me to cover. If you want to see more videos like this, please subscribe my channel and click the bell icon to get notified whenever I upload a new video. Never forget to like and share.